We're Group 11 and the mathematician we chose is Carl Friedrich Gauss. Our goal is to explore Gauss's life, his groundbreaking contributions to mathematics, and his lasting impact on various fields such as number theory. We hope to highlight why he is often referred to as the Prince of Mathematicians. Let me introduce you to our team. My name is Mahima, and I focused on his early life and education as well as the electronic poster. Zane will be covering the relevant texts that are important in the field of math. Finley will be covering the Gaussian elimination, and Hassanin will be covering the prodigy and relationship with Sophie Germain. Starting off with introduction. Early life and education. Carl Friedrich Gauss was born on April 30th, 1777 in Brunswick, which is now a part of Germany. Gauss showed remarkable mathematical abilities at a young age, which really impressed both teachers and family. The Duke noticed Gauss's talent and sponsored his education, which allowed Gauss to attend school and later the University of Göttingen. He later studied at the university where he began to publish foundational work, especially in number theory. A remarkable intuition from his childhood was that he calculated the sum of integers from 1 to 100 in seconds as a schoolboy, which really impressed his teacher, and it marked him as a prodigy. He was often referred to as the Prince of Mathematicians for his immense influence across multiple scientific fields. Gauss's work laid the foundations for future mathematical and scientific advancement, with concepts named after him like Gaussian functions, Gaussian integers, and Gaussian surfaces.
Now, let's take a moment to talk about Carl Friedrich Gauss's contributions to mathematics. Now, let's take a moment to talk about one of Carl Friedrich Gauss's most significant contributions to mathematics, his book, Disquisitiones Arithmetica. This book was published in 1801 and is often regarded as one of his masterpieces and is considered a cornerstone of modern number theory. It introduced many essential concepts such as modular arithmetic and congruences, which remain fundamental in mathematics today. In the book, Gauss presented groundbreaking work on quadratic forms and the law of quadratic reciprocity, which was a major advancement at the time, and these ideas helped shape the way we understand properties of numbers. The influence of this book on number theory cannot be overstated. The methods he introduced revolutionized the study of topics like prime numbers, divisibility, and complex integers. His rigorous proofs set a new standard for mathematical reasoning and inspired generations of mathematics. In addition to his famous works, Carl Friedrich Gauss made many other notable contributions, including some that were never officially published. One key area was differential geometry, where his book on Gaussian curvature became a foundation for the entire field. Differential geometry is now essential in both modern physics and mathematics. And more interestingly, he was known for his perfectionism. He made groundbreaking discoveries in fields like non-Euclidean geometry and magnetism, but often hesitated to publish it because he considered it incomplete. But despite this, his unpublished work had a lasting impact, and his theories on complex numbers, magnetism, and even cryptography influenced future mathematicians and physicists who studied his manuscripts. His legacy has a global reach, and his works has been translated into multiple languages and are still studied in classrooms today. They remain relevant to ongoing research and continue to inspire technological advancements.
Now for the Gaussian elimination. For the Gaussian elimination method, the definition is a systematic method for solving systems of linear equations. The processes are arranging equations in matrix form, use row for operation to reduce to upper triangular form, solves equation through back substitution, and the applications are widely used in linear algebra, physics, engineering, and computer science. So this example I'm going to walk you through. We start with three equations: x plus 2y plus z equals 6, 2x plus 3y plus 3z equals 14, and y plus 2z equals 8. These are rewritten as an augmented matrix for clarity. Next, we eliminate the x term from the second row by subtracting 2x, the first row, 2 times the first row from the second. We get a new matrix. Then we eliminate the y term from the third row by adding the second row to the third. Now, our matrix is in echelon form. From here, we perform back substitution. We start with the last row to solve for z, substitute z into the second row to find y, and finally substitute y and z into the first row to find x. The final solution is x equals 1, y equals 4 over 3, and z equals 10 over 3. Gaussian elimination helps simplify and solve complex systems systematically.
Discussing Gauss being known as a prodigy. Prodigy of mathematics. Initial signs. At just 3 years old, Gauss revised his father's payroll calculations, showing an early gift for numbers. Teachers and peers were starstruck by his ability to solve complex problems effortlessly. By age 7, Gauss solved a tedious task of summoning numbers that left his teacher in awe. As Gauss grew, his accomplishments throughout adulthood earned him the title Prince of Mathematicians. Cementing his prodigy status, Gauss made groundbreaking strides in algebra and astronomy, shaping the future of mathematics and science. Discussing the relationship with Sophie Germain. The collaboration of Gauss and Sophie. Early correspondence. Sophie Germain, a self-taught mathematician, made remarkable contributions to number theory and impressed Gauss with her solutions to complex problems. Despite their mutual respect, Gauss did not offer Sophie the professional recognition she deserved, reflecting the gender biases of their time. However, with Gauss's encouragement, Sophie gained recognition in the mathematical community, though societal constraints still limited her full professional acknowledgement. Sophie Germain's legacy as a brilliant mathematician endures, inspiring future generations in the face of adversity.